So problem, find the Fourier transform of f of x if f of x is equal to e power I omega x if x lies between a and b, a less than x less than b, 0 otherwise. We know from the definition of Fourier transform, so Fourier transform of f of x is given by f of, that is Fourier transform of f of x, which is equal to f bar of p, which is equal to 1 by root 2 pi integral minus infinite to plus infinite e power I px f of x dx. Given f of x which is equal to e power I omega x, x lies between a and b, 0 otherwise. Now Fourier transform of f of x which is equal to 1 by root 2 pi integral minus infinite to plus infinite e power I px f of x dx. So given f of x is valid only in between a and b, the limit a and b, 0 otherwise. So we are splitting the integral minus infinite to plus infinite into 3 parts, right? First, minus infinite to the lower limit a, then the lower limit a to upper limit b, and the upper limit to infinite, right? So we are splitting 1 by root 2 pi integral minus infinite to a e power I px f of x dx plus integral a to b e power I px f of x dx plus integral b to infinite e power I px f of x dx. Now we are going to substitute the value of f of x in the particular intervals, but only in between a and b f of x is valid, that is equal to e power I omega x. Then other intervals the value of f of x is 0. So substituting the value 1 by root 2 pi integral minus infinite to a e power I px 0 dx, because this is the interval minus infinite to a limit, right? In a to b e power I px f of x value is e power I omega x dx plus this is the limit b to infinite, that is other limit, right? B to infinite e power I px f of x is 0, right, into dx. So that is equal to 1 by root 2 pi integral a to b, other two integral become vanishes, so 0 becomes 0, right? Integral a to b e power I px e power I omega x dx, which is equal to 1 by root 2 pi a to b integral grouping e powers, e power I is common, x is common, take it outside, I into p plus omega x dx, which is equal to 1 by root 2 pi. We know e power ax, integral e power ax, which is equal to e power ax by a. Instead of a, you are having I into p plus omega. So e power I p plus omega x by I p plus omega, right? Lower limit a, upper limit b, right? So we are substituting upper limit and lower limit. 1 by root 2 pi, substituting upper limit, instead of x put b, e power I p plus omega into b by I into p plus omega minus lower limit e power I p plus omega into a by I into p plus omega. So 1 by root 2 pi, so 1 by I p plus omega, common denominator, take it outside, 1 by I p plus omega. So in brackets you will get e power I p plus omega b minus e I p plus omega a, that is equal to 1 by root 2 pi 1 by I into p plus omega. So multiplying the conjugate of I conjugate of I is minus I, right? So minus I and divided by the conjugate minus I, which is equal to e power I p plus omega b minus e power I p plus omega a, which is equal to 1 by root 2 pi. So 1 into minus I into minus I square p plus omega e power I p plus omega b plus minus e power I p plus omega into a, 1 by root 2 pi. So minus I by, we know I square equal to minus 1, so minus of minus 1 p plus omega e power I p plus omega b minus e power I p plus omega a, which is equal to 1 by root 2 pi. So minus into minus plus in denominator, so you have minus, so minus I, right, in the numerator, so by p plus omega e power I p plus omega b minus e power I p plus omega into a. Therefore Fourier transform of f of x, which is equal to I by root of 2 pi. So multiplying with minus inside the bracket, so minus e power I p plus omega b. So minus into minus plus e power I p plus omega into a by p plus omega, right, which is the result. So in this here e power I p plus b minus e power I p plus omega a, right, we have to keep as it is, we cannot reduce furthermore, right. So the answer is I by root of 2 divided 2 by 2 pi e power I p plus omega a minus e power I p plus omega b by p plus omega. Thanks.